In this presentation, we will discuss OSI model in computer network and 7 layers of OSI model in detail. OSI model stands for Open System Interconnection Model. OSI model defines how data is transferred from one computer to another computer. In a very basic scenario, two computers connected with a LAN and connectors transfer data using the NIC. This forms a computer network. However, if both systems uses different operating system, for example, one system runs on Windows and other one runs on Mac OS, then how can data be transferred between these two different systems? Here comes the role of a OSI model, which is a 7-layered model that defines how data can be transferred between different systems. There are 7 layers in a OSI model: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer.
There are systems with different operating systems. Every layer in OS model has unique work we will learn in details. When sender sends data, first of all it goes through application layer, then downward through each layer it passes through transmission medium, and receive gets the data finally as shown.
Application layer is used by computer applications such as Google Chrome, Outlook, Firefox, Skype, etc. Application layer defines the protocols that are used by computer application. For example, HTTP and HTTPS protocols are used by web browsers such as Google Chrome, Firefox, Safari, etc. FTP protocol is used for file transfer between two or more computers. SMTP protocol is used for emails. Telnet is used for virtual terminals. There are dozens of other protocols that forms application layers such as NFS, FMT, DHCP, SNMP, POP3, IRC, and NTP, etc. In short, you can say that application layer provides a service to computer applications with the help of protocols that are defined in it.
Presentation layer receives the data from topmost layer, which is application layer. There are 3 functions of presentation layer. There are translation, encryption, and compression. Here in translation, the data received from application layer is in form of characters and numbers such as 1, 2, 3, 4, ERFF, and etc. The presentation layer converts these characters and numbers into machine understandable format, which is known as binary format, or for example 100111001. Function of presentation layer is the compression. It is to compress the data to small size so that it can be transferred faster over a network. This compression can be lossy or lossless compression. Encryption is to protect the sensitivity of data. Presentation layer encrypts the data at the sender side before the transmission, and the receiver side. This data is decrypted by the presentation layer at the receiver side. Secure sockets layer protocol is used by the presentation layer.
In the 5th layer of OSI model, we have session layer, in which it maintains the connections between different systems, and it is responsible for controlling ports and sessions. Session layer, however, has 3 main functions, which are authentication, authorization, and session management. For authentication, before a computer can be connected to a server, the computer has to provide username and password for the authentication. The function of authentication and setting up a connection after authentication is performed by session layer. The second one, we have authorization. Once a connection is established, session layer checks whether the connected computer is authorized to access the data. This function of authorization checking is also performed by session layer. And the last one, we have session management. Session layer also checks that the data which is received from the server in form of data packets belong to which application. For example, when you access Facebook profile through your browser, the data transferred from the Facebook server is transferred to your web browser. Thus, the session layer helps in session management. Since session layer is responsible for maintaining connections, streams of data are marked and synchronized properly, thus we can see that the data loss is avoided.
Transport layer. The main role of transport layer is to check the reliability of the communication. The main functions of transport layer are segmentation. Segmentation data received from the session layer is divided into small data unit called segments. Each segment contains the sender and receiver port number along with the sequence number. And flow control. It's control the flow of data. It's check the capability of the receiver device receiving capability before transmitting data. For example, a sender server can send the data and rate of 100 Mbps, but receiving data can only receive data in the rate of 10 Mbps. Then it's control the flow of data to 10 Mbps so the data doesn't get losing during transmission. Error control. Transport layer also performs error control using automatic repeat request. If a data is lost using transmission, it is sent again using automatic repeat request. Transport layer also adds a group of bits called checksum with its segments to check whether the data received at the receiver side is not corrupt. Connection-oriented transmission. Connection-oriented transmission is done using Transmission Control Protocol or TCP. TCP is considerably slower than UDP because it provides the feedback that the data is received or not. The data can be sent again, not received. Connectionless transmission. Connectionless transmission is done using User Datagram Protocol or UDP. UDP is the faster than TCP because it doesn't provide data is actually received and receiver side.
Network layer. The main purpose of network layer is to receive the data segments from transport layer and transfer them from one computer to another computer on different network. The main function of network layer is logical addressing. Every computer on a network has a unique IP address. Network layer assigns the sender and receiver IP address to data packets before transmitting them so that the data packet reach the correct destination. Second is routing. It is a method of transferring data packets from source to destination. It uses the combination of mask and IP address to transfer the data to correct destination. Each data packet contains three additional components: mask, sender IP, receiver IP. The mask determines the computer network to which the data needs to be delivered, and then the IP address determines which computer on that particular network needs to receive the data packet. And the third is path determination. A computer can be connected to another computer in a number of ways. Network layer determines the optimal path for data transmission so that the data can be transmitted faster to the receiver. OSPF, BGP, ISIS protocols are used to determine best possible path for data delivery.
Data link layer. Data link layer receives the data from network layer. There are two types of addressing done to the packet transfers from one computer to another computer. Logical addressing. Logical addressing is assigning sender and receive IP addresses to data packets. This is done at the network layer. Physical addressing. Physical addressing is done at data link layer where MAC addresses of sender and receive are assigned to each data packets. Data unit in the data link layer is called frame. A frame is a transfer from one computer to another computer, and transmission is through a transmission media such as wire, cable, and etc. Both sender and receiver computer has NIC that helps in sending receiving frame. This NIC present the sender and receiver provides the physical link between sender and receiver. Main functions and data link layer. Access the media allows upper layers of OSI model to use a media use technique called framing. Media access control. How data is placed and received from the media. Error detection. Tail of each frame transfer contains certain bit. Check whether the data received on the side is corrupt or not.
Physical layer. Physical layer converts this binary sequence into signals and transfer it through a transmission media, such as cables and etc. The signals generated by physical layer is based on the transmission media. For examples, an electrical signal is generated if the media is copper cable. Light signal if media is optical fiber, and radio signal in case of transmission media is air. This generated signal is received by the physical layer at the receive side and converts it into bits. Main function of physical layer. The main function of physical layer is digital transmission. Digital transmission is one of the main functions of physical layer is to transfer data form of signals. In this guide, we will learn about digital transmission. A data can be either analog or digital. To transfer the data over a transmission media such as a wire, cable, and etc. Physical layer must need to convert the data to its digital signal. Digital data or digital signal conversion. In this section, we will learn how physical layer converts digital data to digital signal. It uses two techniques to do this conversion: line coding and block coding.